Here is a question to show that whether the weak law of large numbers holds. So the question is like this. If xi is a random variable which assumes values I and minus I with equal probabilities, show that the weak law of large numbers cannot be applied to the sequence x1, x2, etc. xn. So it is given that I and minus I are taken by the random variable xi with equal probabilities. So we can write probability of xi is equal to I is equal to probability of xi is equal to minus I is equal to 1 by 2. Since it is said which assumes values I and minus I with equal probabilities. So therefore, we can find expectation of xi. Expectation of xi is equal to 1 by 2 into I plus 1 by 2 into minus I. And this is equal to 0. So therefore, expectation of xi we got as 0. Now, variance of xi is equal to I square into its probability, that is 1 by 2 plus I square into 1 by 2, because it is I and minus I. So on squaring, this is I square and this is also I square. So this is equal to I square. I square by 2 plus I square by 2 is I square. Yes. Now we need to check whether the Bn by n square is tending to 0 or not. We have a condition that the weak law of large numbers holds only if Bn by n square tends to 0. So we are going to check if Bn by n square is tending to 0 or not. So Bn is equal to variance of x1 plus etc. xn, which is equal to variance of xi is I square. So variance of x1 is 1 square. Variance of x2 is 2 square and etc. So this is equal to summation I equal to 1 to n I square. And we know that, isn't it? Like summing 1 square plus 2 square plus etc. up to n square is n into n plus 1 into 2n plus 1 divided by 6. Yes. That is 1 square plus 2 square plus etc. plus n square is equal to n into n plus 1 into 2n plus 1 divided by 6. Yes. So from there we have got Bn is equal to this value. Now we need to know Bn by n square. Bn by n square is equal to n into n plus 1 into 2n plus 1 divided by n square into 6. So I am going to divide each term by n square. So that is equal to what am I going to take? I am going to take n outside. N into 1 plus 1 by n. So I am going to take n square outside. From this term also I am going to take an n outside. So that is 2 plus 1 by n. So this will be n cube divided by 6 into n square. So this term and this cancels. So this is equal to n into 1 plus 1 by n into 2 plus 1 by n divided by 6. Now what we are required to check is, we have to check Bn by n square. Limit n tends to infinity, Bn by n square is equal to what? So here limit n tends to infinity, Bn by n square is equal to, what is it? In the denominator, as n tending to infinity, there is no n term. So we have only the concentration on the numerator. And in the numerator, it is infinity into 1 plus 1 by infinity. 1 by infinity is 0. So what can we do? N into 1 into 2, isn't it? 1 by n is again 0. So this term is infinity. So then, since this Bn by n square is not equal to 0, we can say that this sequence x1, x2, etc. xn, which takes where xi, the random variable, assumes the values I and minus I with equal probabilities, does not satisfy the weak law of large numbers. That is, the weak law of large numbers cannot be applied to the sequence x1, x2, etc. xn. So in this way, we can check for any of the sequences x1, x2, etc. xn with any of the values. We can check if it holds the weak law of large numbers by checking if limit n tends to infinity Bn by n square is going to 0 or not. If it goes to 0, or if this limit is equal to 0, then we can say that that sequence satisfies or holds the weak law of large numbers. And if it doesn't, or if it is a diverging one, then the weak law of large numbers cannot be applied to that sequence.